afternoon to everyone. It's just after lunch, so imagine it's a time of digestion. And I can see some people just thinking, okay, yes, indeed. So don't annoy us. But here we are at Sanofi, we're happy people, we're energizing people, and we want you to have a fantastic experience. So just to start, I just want to make sure everyone is aware of the body right now. So I will ask you just to tap on your body, just to re-energize your body everywhere. If you can do it, you are making your blood circulation is really good, especially if you are moving. And now back to my hands, crossed. And that's the moment where I will ask you just to relax a little bit, everything over here. How are you feeling? Not very good. I can hear the no. Okay, a little bit of stretching over here. It's really good, trust me. It's really helping you to stay awake after this whole thing. And a little bit of this. Okay? This with your feet. Come on, come on, come on, come on, come on. Come on, come on. Where is the energy? I can't feel the energy. I can see the energy is really low. How are you at Sanofi's booth? Okay, so see, it needed a little bit of warm-up. So let's start our session. I needed to warm them up so that they're ready for you guys. So let's talk about an interesting topic this afternoon. We will talk about digital ballroom twin. You will know about that in a few minutes. How do we use AI technologies to adapt Sanofi's industrial assets to planned or unplanned demand? So for that, please welcome our next speaker. Both of them are from Sanofi, obviously, Jakob Harttung and Thomas Gautier. So they're ready. I've warmed them up. Now you can.
I see expectations are high now.
They are high, actually, because you see that the energy is still a little bit low, but they are here, and we're really happy that you are here. So before we dive into this digital ballroom twin, let me ask you a question first, Thomas. In which context this concept has emerged?
Okay, thank you, Christina. Clearly, the COVID period was very challenging period for all the pharmaceutical world. The pharmaceutical company has to adapt quickly to an unplanned demand. It was really a challenge, not only a challenge for research and development team, but also for manufacturing team. This is when Sanofi decided to design and to develop a new type of manufacturing building based on standardization of process with a much more agile and flexible approach. Its innovative design is based on process platform. A process platform for us is a technique that we use to produce our vaccines or biologics. For example, we are speaking about fermentation, cell culture, so on. This process platform can be installed within a single open space, which is called ballroom. In this ballroom area, you will find utility panels that are installed strategically in order to put in place in a flexible way the process module that we use. A process module is a set of equipment that we use in order to produce a unit process step. For example, chromatography, filtration, or so on. So of course, the agility of this building is completely linked to the data domain and the digital domain with a seamless digital data connectivity.
And let's get into the heart of our matter, talking about digital ballroom, and even what is it first? And maybe what is a digital twin? I remember asking you that a few years ago already.
Yes, it's not a new topic, but we are bringing it to a new level here. A digital twin is quite easily, it's a replica in the virtual world of something in the physical reality, creating a mirror of physical equipment into something which is in a digital environment and keeping those two synchronized in order to optimize activities, to simulate how we're going to use things, and doing that in the virtual world before doing it in the physical. We've got digital twins in lots of different areas. We leverage them in different parts of the activity and organization, focusing either on digital twins on our specific biomanufacturing process. We've got digital twins of dedicated equipment. But here we're talking about something slightly different, which is a digital twin of a full production area, the ballroom. And having the digital twin of the production area with the setup of the different equipment, especially as we're moving those equipment around within the context of the modulus concept, we'll get to modulus, of a modular factory, it is exactly that, the digital twin of the setup within the ballroom area.
And Thomas, you have actually innovative features and capabilities, obviously, of this next generation manufacturing facility. Tell us more.
Yes, in the coming year, as you may know, Sanofi will have to launch numerous new products across various therapeutic domains in order to ensure the clinical development and the patient supply. Sanofi needs assets that can be switched between products. So let's take a few minutes to look at the inauguration movie of this new type of building.
So what is Modulus?
Yes, Modulus is a groundbreaking and modular vaccines and biomedicine production facilities. Two things are very important to understand with this building. The first one, Modulus can transition from one product to another one in a rapid time. We are speaking about days. The second one is that in Modulus we can produce up to 4 different vaccines simultaneously. Clearly, it's a challenge that traditional manufacturing approach simply cannot meet.
And tell me, what's the difference with the current ones, basically? What's the main, let's say, difference between the new one now, Modulus?
Yes, traditional manufacturing building face several limitations. The first one that you have ici, they can produce single vaccines, making them costly and underused as soon as you have product portfolio evolution for any reasons. The legacy facility lacks the agility to adapt quickly to an unplanned demand. It was, as you may know, developing a new medicines or constructing a building takes significant time. We are speaking about years. And due to our complex portfolio, of course, of product, but also about complex administrative modality that you couldn't find in different countries. In the technical point of view also, we are developing new vaccines with higher productivity, smaller batch size, and shorter campaigns. In this case, Sanofi needs more flexible small asset than a large dedicated one. This challenge is completely challenging the manufacturing operation, but also the digital part.
And tell us, Jakob, what's the ambition behind that? Fantastic, it looks fantastic, but what's the ambition behind that?
Yeah, so digital is a key component of this concept, actually. You may have heard that one of our key digital missions within Sanofi is to drastically reduce the time it takes to go from discovery of a new medicine to patients actually receiving it. And this is a key enabler of that. From a digital perspective, we'll of course get back to the ballroom twin as a key element and its ability to do virtual commissioning, reusing standard pre-configured modules and optimizing flow as we reconfigure a factory. But before that, maybe it's also one of our, or actually the most standard state-of-the-art and modernized digital facility that we have across the full network. We have taken the best that we have across all of our factories and put it in here, and then we added a few things. A key elements that we need is, in order to support this modular concept, we need to have all of the different layers of technology that are also modular. So we have the basic infrastructure, we've got the networking, we have optimized cybersecurity, but of course cybersecurity is increasingly important, and when we reconfigure, there are elements of threat within that. We've completely changed the connectivity layer because we have got full connectivity, of course, all operations within the factory with sensors on equipment, on the building, on the environment. And that needs to adapt to the changes of production plans. And so that is a full layer of connectivity. So we have the data, we can use the data, analyze, optimize, apply AI capabilities on that. And so we're using all of the existing solutions on AI, be it on optimized planning, scheduling, yield improvement with our solution called Simply, leveraging those across the board. And then in the end, of course, the most important element is how do we enable the reconfiguration and the use of this modular concept. So we go from doing one product to another product, doing 3 different products, adding a 4th one, introducing a new technology. And that's what the bolder trim will be. We'll talk about it a bit later.
And back to you, Thomas. Basically, Sanofi is targeting carbon neutrality by 2030. What about the environmental impact of this building?
Yes, the construction of this kind of building fits with 3 main objectives that you have here. The first one, of course, is to be as possible a neutral carbon footprint. To manage this objective, for your information, we installed 2,500 square meters of solar panel across the entire area of the roof. The second one is to consume as less as possible energy, of course. We managed to consume less than 80% of energy than a traditional size building with the same size. Of course, our waste will not be landfilled, and we try to maximize the recycling of this waste. Adherence to this objective will lead to obtain the LEED Gold certification of the US Green Building Council. This certification is planned in September of this year.
And tell me, how many of these buildings do you have in the world?
Yeah, we have two buildings in the world. We have one in Singapore and another one in France, in Neuville-sur-Saône. In Singapore, it was a greenfield project. That is to say that we started from an empty plot, nothing existing. We built the manufacturing building, of course, but all the other buildings that you can find, like QC control, warehouse, and so on. In contrast, in Neuville, it was not the same. Neuville was already a manufacturing site for us, with other vaccines already in place. So we leverage the existing building that we have across Neuville.
And what about the inside, let's say? How does it work? How does it look like?
So you can see the picture there of Neuville-sur-Saône Modulus. So this building is not only a manufacturing building. On the ground level, there you will find all the management of utility, production of utility. We are producing sterilized water, steam, and so on, all utility necessary for production. And we have also a warehouse supply of our raw material. In this picture, you can see that the warehouse of the site is completely directly linked to the Modulus building. On the second floor, you have a manufacturing operation area. So here are located the media and buffer production, and the ballroom we are speaking just before is this U shape in the building. And the last level, we have all the equipment necessary to control our air and purify the air of our area.
And I think in Singapore, you inaugurated it recently, didn't it?
Yes. In Singapore, you will find exactly the same building that you can recognize there. You have the empty plot that's used on this area. And in front of the Modulus building, you will have a QC, quality control building for our sample and the administrative part.
So let me come back to you, Jakob, about the concept of digital twin. How can it actually help the factory to switch from one process, one product, let's say, to another in a record time?
Great question, and we get to that. We built the digital twin through the whole life cycle of actually building and creating the Modulus facility. And so we had all along that life cycle the complete model in parallel to what we are setting up. So we could validate how the equipment was set up, how it's connected to different parts of the equipment, how we plug it into what Thomas called the docking stations, the place where we get electricity, energy, utilities. And so being able to validate upfront before actually doing things, how it would be set up and whether we could operate it efficiently. We also used that actually for some of the operators so that they can see what it would look like. We started setting up the different procedures, training of the operators in this full environment, and where we had, as you can see here, the level of detail down to the slightest equipment, how they are connected, branching assemblies, and so on, creating that element. So really getting the full picture of what it would look like even before it exists.
And is this tool actually used when it's completed? Do you still use it?
But of course, even more actually, because the first setup is the easiest one. Don't start the video. The first setup is the easiest one. The key is really when we start operating this, and we started in the opening September of last year, we reconfigure the plant. And it's more difficult to reconfigure because a production line, as we said, we can do 4 different productions in parallel, is a set of multiple equipment. You can have tens of equipment. They need to be put up in the right phase, in the right timing, connected at the right place, putting together different equipment if they are needed. And we can actually simulate that changeover with the full model of what are we starting from, where are we going, and then having that automated flow of activities going from one position to the other. And that's how we enable an accelerated changeover from one product to another. We used to do it in months. With this new capabilities, we can change from one production to another in a matter of days, maybe a week. And so that acceleration is one of the key values we're getting out of it.
So that's really key to accelerate the whole process, actually. Let's come back to the features and maybe show a video talking about that first.
In September 2024, Sanofi inaugurated Modulus, a groundbreaking vaccines and biomedicines production facility in France at Neuville-sur-Saône. Fully AI-powered, Modulus features next-generation technology that can be reconfigured in days to address urgent and unplanned public healthcare needs. The Ballroom Twin is one of the Modulus AI-powered enablers to achieve a plant reconfiguration in less than 7 days. It's a living model of the shop floor, simulating setup of manufacturing lines with 3D representations. It enables defining, assessing, and confirming the plant reconfiguration scenario in virtual reality, allowing to be first time right in the execution. By helping to reduce launch cycle time and optimizing Modulus performance, the Ballroom Twin plays a key role in our journey to become the world's leading immunology company, leveraging AI at scale.
Very exciting, actually. So tell us more. Oh,
It's me. I'm still here.
It's you.
So indeed, as you saw the kind of concept they were looking at, and the features we get out of it are going into a bit more details on some of these. Of course, the key objective is the accelerated production setup. And we are using also a certain number of capabilities so that we go from where we are to where we want to go with an automated generation of what are the different steps. We are using pre-configured environments, pre-configured standard assets that we know how to assemble, and so the system will automatically suggest and recommend what is the best approach, how do we set them up, how do we set them up next one to the other, and what is the flow of actually pulling these different things together. Another element that we do in the which accelerates things is what we call virtual commissioning. As I said, an equipment you need to position in the ballroom, you need to plug it into the docking station with electricity, water, utilities. Think about setting up a washing machine at home. You know, getting it into the right place, making sure you've got it connected to water, that you don't forget to put water out also. That is the virtual commissioning. We put everything into the digital model, validate, simulate in that environment. When we know it's good, we replicate in the physical world, and that's what creates the value in the existing configurations. And same thing with the flow optimization. You saw in the video, we've got lots of different equipment moving back and forwards. We have to do that in the right order, have to make sure things can come out in the right place. When we ask an operator to set something up, it needs to fit in there. You can't have something else in the same place. Making sure that whole flow is actually seamless, that is exactly the kind of value we get out of it. So when we start actually putting up the ballroom configuration for our production, everything works right first time, no surprises, and no time wasted.
Thomas, how does this technology bring a strategic value to the operations, the manufacturing operations?
Yes, clearly this modulus building creates significant strategic value for Sanofi manufacturing cooperation in multiple dimensions. As we have seen, the first one is the design of a building. The design of a building facilitates quick changeover between product configuration, reducing time to design environment. This is the first one. The second one is the digital part. The ballroom digital twin support anticipation and preparation for right first time setup for our new products. Clearly, these capabilities are addressing a huge challenge that we have in Sanofi for the portfolio of product evolution. In the coming years, Sanofi has planned to launch more than 10 new blockbuster products in immunology, for your information.
And tell me, how does it optimize the performance in a few words as well?
Yeah, maybe if I could add to that. And just in the end, the goal is the patient. And if you were here earlier, the previous session, we talked about that, is how do we get a new medicine out to patients as fast and early as possible. And so a key element of that is really when we don't waste time doing a changeover, setting up a new production, when we go from 3 months to a week, patients get their treatment faster. And that is really the key goal of what we're looking for. Now, from a more operational financial perspective, we also have better performance. But once again, the changeover. During those 3 months that go to 1 week, that is additional batches we can produce. We are having more output from the facility, using the same asset, the same investments, but getting more medicines. And in the end, more patients will be able to be treated. And that's what we're working for in our dream.
Indeed, so the idea is to get the medication faster to the patients.
And more patients.
And more patients, yes, because the production is actually bigger. Great, well, a great applause to you. Thank you very much.
Thank you.
Do we have questions in the audience? Any questions? Yes.
You shared about business value, and it's great to see. Maybe you can share some sneak peek of how does it look like from technological perspective. What did you use to implement those process simulation, flow simulation, and design optimization technology?
Yeah, great question. We use different elements. We don't have just one solution off the shelf that we can buy. A lot of the technology is based on the design of the concepts of the modular equipment and how we set them up and creating that technology from different areas. We've got standard DCS technology, we've got historian equipment connectivity and so on, and the data flow is an important element. Specifically on the ballroom twin, we've worked essentially with Dassault Systèmes and 3D experience environment, creating the model within that, but then adding different capabilities in order to optimize what is basically in there, adding a few AI capabilities. One of the things that we've worked on typically is, once I change the setup, I also need to change a certain number of operations, for instance, environmental monitoring control. The different change points, checkpoints, the different sampling points need to be optimized to the configuration of the manufacturing, and those are kind of elements that we would be adding with different technologies.
Maybe just as a quick follow-up.
We'll put back the mic.
Yeah, quick follow-up on that. Do you consider to having physical and chemical simulations as well as the part of that flow? Do you think it's feasible at all, or there are some blockers to implement that?
Great question again. One day, we will have one single twin, everything working automatically. A few people in the factory, but everything automated. For the moment, we're still optimizing different elements. So we have, actually for some of the products we have within, maybe you should talk about that rather than me, but for some of the products we have within the facility, we've done simulations of the biological process, on fermentation, other parts of the manufacturing step where we have dedicated twins. Here we have focused on one key area, which is the performance aspect of the modular facility, and created a twin that optimizes for that. One day we'll probably pull them all together into one big model. Bit too early for the moment.
Any other questions? Well, thank you very much again. Thank you.
Thank you,
Great,
Christina.
fantastic facility to improve people's lives at the end.
And by the way, if you want to know more about it or see more what it looks like, we have a wonderful booth over there with demonstrations of the model of the facility that you can actually experiment. So please go over there and you see great demonstrations.
With the virtual reality,
With the virtual reality, exactly.
glasses. Thank you very much. A great applause again, please. Thank you.